So in this video, I will talk about Vega within the context of the previous example, and many of these things are conceptual. So for this reason, let's just focus on the big picture and the intuition behind them. With that said, let's get right into the content. So remember from my previous lesson, we had a European call option that matures in 1 year, has a strike price of $105, where the current price of the underlying is $100. And remember, we had an investor who reached out to a trader and said, I want to buy 1 million of these call options. How much would you ask? And the trader collects some additional inputs about the options, such as the risk-free rate, along with the volatility, to calculate the theoretical value of this call option. And long story short, he concludes that the theoretical value of this call option is $9.56. So he thinks for himself, okay, the theoretical value of this option is $9.56, so let me sell them at $10 per option. And now he gets back to the client and says, okay, I will write them at $10 per call option. And this is how the two strike a deal where the investor is long 1 million call options, while the trader is short 1 million call options. And the trader is very pleased because he just made a gain of 0.44 million by selling the options above the theoretical value. So up to here, it's basically the same story we saw earlier. Now, the twist in this lesson is that in the meantime, the volatility increases to 28%, which causes the value of the call option to rise to $10.75. And this is where the trader becomes sad, because at this point he made a loss as he sold the option at $10 while the theoretical value is now higher. And the question over here is, how could he have managed this risk? And this is where Vega hedging comes into play, and this is what I will talk about on the right-hand side of the screen. And speaking of definition, Vega is the sensitivity of the option's value to changes in volatility. And this is how Vega is defined in a formula. Now, in terms of how Vega is calculated, this is quite technical, and I don't think that you would be tested on this on the exam, so please don't worry too much about it, and let me walk you through it from a big picture perspective. So basically, Vega is calculated using this expression over here, where n'(d1) is the derivative of the cumulative normal distribution, which is basically the height of the standard normal bell curve at D1. Now, please don't worry if that sounds too technical. This is not something that you would be tested on. And these formulas might look convoluted, but they are basically a simple plug and play. And this is because we already have D1 calculated, and based on that, we can come up with the value of n'(d1) to be this much over here. And once we know n'(d1, the calculation of Vega is another plug and play, leading us to this value over here. And basically, the way we interpret this value is that if the volatility increases by 1%, the value of the call option would increase by $0.3973. And the curriculum is also illustrating the relationship between Vega and the stock price. And conceptually speaking, here is how I want you to look at this. In the case of a call option, the lower the stock price, the deeper out of the money the call option would be. And the higher the stock price, the deeper in the money the call option will be. And in the case of the put option, the lower the stock price, the deeper in the money the put option will be, while the higher the stock price, the deeper out of the money the put option will be. And in terms of what the curriculum is highlighting, which is a very important observation, is that Vega is lowest when the options are either deep in the money or deep out of the money. And this is because in those areas, whether it's a put or a call, there is most certainty. And of course, this is because in the case of deep out of the money options, it is very unlikely these to be exercised, while in the case of deep in the money options, it is very likely for these to be exercised. And it is this certainty the reason why the sensitivity to volatility is low. And if we look at the middle of this illustration, this is where Vega is the highest, and this is because this is where there is most uncertainty. And this is where the sensitivity to volatility peaks. Now, the curriculum also illustrates an example of how to hedge Vega in action. And in this example, we have our current exposure in option A, and we have a hedging instrument called option B. Now, please note that both options are written on the same underlying. Now, our current exposure to Vega is minus 500, while our delta exposure is 0, which basically means that we are delta neutral. In the meantime, the hedging instrument has a Vega exposure of 2.5 and a delta exposure of 2. And the question is, how can we hedge our Vega exposure? And this is actually very simple. All we need to do in this case is to write up the hedging equation and solve it for x. Solving this for x, we get 200, which basically means that we need to go long 200 units of option B. But the story doesn't end here, and this is because by doing this move, we are not delta neutral anymore. And of course, this is because our delta exposure becomes 600 after hedging Vega. And remember from my previous lesson on how to hedge delta, in order to remain delta neutral, we need to go short 600 shares of the underlying. So this is how we hedge our Vega exposure while keeping our position delta neutral.